Okay, awesome. So I'm here starting up with Geometry and Trigonometry 2. So for those in DP2, this is actually going to be our second to last new unit for the year. So it's pretty cool. So we have some vocab. So let's start. Let me get a marker. Okay, so let's start with point. We've seen point in a lot of other stuff before. A point is just a point. A point is actually zero-dimensional. So this is zero dimensions. You should be familiar with point. And then a line actually is in one dimension. So a line is built from 2 points. 2 points, and it's the line in between the 2 points. A plane, I have an example here, is like a piece of paper. It's kind of hard to draw because it's really thin and plain. This one is actually two-dimensional. And then we have a solid. I have a couple solids here, like this tissue box or this math bingo box. Okay, so solids are in 3 dimensions. Okay, so point 0, line 1, plane 2, solid 3. So you'll have to find out about dimensions in a little bit, but for now, just remember it goes point 0, line 1, plane 2, solid 3. Not too bad. Okay, now because we're in math studies, we actually only have to deal with basically one type of prism, the right prisms, which, if you remember triangles, right triangles are basically your best friend, so right prisms are your new best friend. Okay, so right prisms, I'll use this tissue box as I'm explaining it. So it says end faces are the same shape, size, and are parallel. So if this is our end face, then the other side is the same shape, it's the same size, and they actually, you can kind of see there, they run parallel to each other. Okay? And then all the other faces are also rectangles. So we have a rectangle here, a rectangle there, and they're perpendicular to the end face. So this is the part that's really helpful when we're problem solving because we know something about perpendicular lines. And that is that they create 90-degree angles. So if we have these perpendicular shapes, we know we're going to have perpendicular lines here. We're going to have these awesome 90-degree angles, which are really fun to work with, and it makes your life a little bit easier. So that's right prisms. I went ahead and drew this awesome right prism here. So it's this, but drawn. So we have a face. It could be a face here, it could be a face here, but it's when it's one whole face. So a face is like a plane, and then we have an edge, which is just this part, just the edge of a box where it makes that 90-degree angle. An edge is a line, and then we have these vertexes. So we have, I drew this one here. We also have here, 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 and don't forget the one in the back because you're going to have to learn how to count vertices. So that's a vertex, and a vertex is a point. Okay, so that's to do with right prisms. We have one other thing about right prisms. It's called a cross section. So cross section is the same shape and size as one of the end faces, but it's just cut parallel. So it'd be like if we had this tissue box and we have this end of the tissue box, right? If we were to cut a slice right here and make a little slice of it, it would also be the same shape and size. So that would be a cross section of this right prism. Okay, cuboid versus cube discussion. Hopefully you guys have heard a little bit about this before, but now that we're dealing with 3-dimensional shapes, we get to deal with this fun word, cuboid. So a lot of people are familiar with cube because it's kind of a common language, but not so many people use the word cuboid. So you can kind of think of this back in 2D geometry and trigonometry. We talked about squares versus rectangles. So a square is when all the sides are the same, and a rectangle is when 2 of the sides are the same, but not all 4 sides are the same. So that's kind of the same with cuboid. So a cube is all your sides have to be exactly the same. It's a beautiful little cube, kind of like imagine a die, and then a cuboid can be a three-dimensional rectangle, basically. It doesn't have to have all the exact same shapes and sizes. It can just be like our beautiful tissue box, okay? So cuboid versus cube, good to keep in mind, good language to know. Some other stuff, besides rectangles, we're also going to deal with some three-dimensional triangles. So a three-dimensional triangle can be called a pyramid. So a pyramid, I think you guys know of some really famous ones in North Africa, the Great Pyramids, so you can think of pyramids. And at the top of the pyramid is the apex. So that's kind of similar to a vertex. It's an apex. You see the same ending, X, X. It's just the joint at the very top of the pyramid, okay? And then when we're looking at this type of curved right, this is a right cone. So we have some other stuff about right cones. So this is a right cone where the apex is directly above the center of the circle at the base. So that makes it really easy for us because then we know that if we drop a line from the apex to the center, it's going to hit at a 90-degree angle. And that is what we need to get the vertical height. So if we go from the center of the right cone all the way, I'll write that this is a right cone. We go from the apex up here down to the O, which is the center of the right cone, we get the vertical height. And likewise, if we go from the apex to any point around the circumference of the base, we'll get the slant height. So that will tell us how long this slanted side is. So those are two different measurements because, as you can see, they make this triangle where the slant height would be the hypotenuse. Okay, so lots of fun vocab, lots of new shapes. Yeah, the first section is pretty basic, talking about, let's see, writing down names of shapes. Just look at the book and see what they have. Counting edges, counting faces, counting vertices. That stuff should get you started. Okay, awesome, thanks.